So now comes the part where you are going to take your wafer that's done baking for the specified amount of time that we looked up in our protocol, and we get to define our features by exposing the wafer to UV. And what we're going to do is use a mask to define those features. And one important part about the mask is that one side of the mask has ink on it and the other side doesn't. And so technically what we want is the ink side down on the wafer, and the reason for that is we want that black surface to be right on top of the epoxy to define a very nice tight shadow. If it was on the other side, the thickness of the transparency will be between the ink and the epoxy, allowing for less precise features. And so typically from our manufacturer of transparencies, if you can read the writing that you put on it, then it's in the correct orientation, so you should put it face down like that. So we're going to take our wafer. We're going to place it on a pedestal here, but before we do anything, we're going to gauge the intensity of the UV light. So this is the Omnicure. It's a very simple device that has an on and off button right here. It takes a few minutes to start up, and then it has a start-stop button, and it also has an up and down button setting the time. The way we determine the time is again in our SU-8 protocol. So if we look in here on the adjacent page, there's a graph for exposures. And so we look at our film thickness, 250. We look up here, we're at about 700 millijoules per centimeter squared. So that's the amount of, or the dose of energy that we want to put on our wafer. So in order to determine the dose that our light will produce, we need to look at the intensity of the light. On this shelf is a radiometer. The white spot is the sensor. There's an on-off switch, and the units are in milliwatts per centimeter squared. What I do oftentimes is I set up a pedestal that's slightly lower than what my wafer is at, because the sensor is slightly higher. I turn it on. I focus the beam using this lever. Then I measure around the perimeter, and I read the number. It's at about 6.5 to 7. So I'll use 6.5. Turn this off. Make sure to turn the radiometer off. It's very easy to leave on. And if it is left on, we undo the screws and replace the battery. It's a simple 9-volt battery. So now that we know that the light is delivering 6.5 milliwatts per centimeter squared, and we want 700 millijoules per centimeter squared, take out our calculator and we'll take 700 divided by 6.5, and that's how many seconds we want to expose our wafer for. So 107 seconds. So here we use the up button because the number's too low, and hold it down. And we are at 107. This wafer is already developed, but it's just a prop. But usually it would be a uniform layer of epoxy that's been pre-baked. We take our mask, we put it the correct face down. We take a piece of glass, and we're going to place it over the top to hold the transparency uniformly across the wafer. And if there are already features in our wafer that we need to align to, we can use any excess transparency to move this over the top of the wafer and align it. With it aligned and the glass on, then we would take and turn it on to center it in the light. And if desired, you can also use this pedestal to rotate it so that if there are any low spots of intensity, they're distributed around the device. But be careful not to bump the transparency, as then that will affect your alignment. And then when it's done, we lift it off, place it back on the hot plate, and we look at our SU-8 protocol again. And then the final spot here is in the post-exposure bake, the PEB. And so this is relatively short compared to the pre-exposure bake. And so we look up 250 microns and it says for 20 minutes. As just a note, when you're doing your soft bake, the long first bake, if you add layers on top of layers, let's say we have an initial 250 micron layer that should be cooked for 2 hours, and then we add another 250 micron layer that supposedly should be cooked for 2 hours, but it will need more than that because there's an overall total thickness that we have to try to get the solvent out of the SU-8 for. So you could be ultra safe and just add those two amounts and bake it for 4 hours, but it's likely somewhere in between. But if you wanted to be extra safe, you add those 2 amounts. So once it's post-exposure baked, and it cools down, we can repeat the process over again, and put it on the spin coater and spin another layer and make more features.